Some of you who learned your skills before synchronous technology arrived, have been reluctant to explore synchronous modeling. One purpose of this video is to help you get comfortable with design intent and the solution manager. Also, some of you might have tried top-down assembly design when it was more complex in the past, with inter-part relationships that you had to manage on your own. We want to show you that developing part designs within the context of assemblies has never been easier than with Solid Edge today. In the next few minutes, we'll show you how to get started with synchronous modeling. You'll see how synchronous modeling recognizes your design intent, frees you from the cumbersome mechanism of history-based modeling, and lets you focus on creating designs, not managing your CAD system. Synchronous modeling, just like history-based modeling, starts with a sketch. Solid Edge recognizes any closed regions in your sketch. To form a solid feature, select a region, grab the control handle, and push or pull to define the feature. Once there's a solid body, grab faces on the body and pull them to develop the model. Your design intent is in the model itself, not the sketches that started it. As you modify the model, Solid Edge sees and analyzes every geometric aspect of the design, such as symmetry and coplanar conditions. Live Rules is the tool that tracks these geometric conditions, and it's your tool for controlling the model. Preserve your design intent as you edit a synchronous model by using Live Rules to adjust which geometric conditions Solid Edge recognizes and maintains. Use PMI to drive, or merely reflect, dimensions on the model. Use variables and formulas within dimensions to make the model parametric. You can define 3D geometric relationships to maintain design intent for special cases that Live Rules would not recognize. Think of these like 2D relationships you might have used in the past. Solution Manager gives live feedback as you work to help you visualize the geometric rules governing your modifications. Use synchronous and ordered techniques together, in the same model, to best express your designs. The greatest benefits of both techniques emerge when you use them together. In the next couple of minutes, you'll see how design intent relationships in Solid Edge help you develop your design. You can make changes to a 3D model face rather than a sketch. During this video, you will also see how Solid Edge recognizes face relationships without any forethought or pre-planning. Let's see design intent relationships in action with this tool holder part. After selecting a face, the design intent panel shows symmetric and coplanar faces so you can decide whether or not to maintain those geometric conditions. Moving the hole on the tool holder, the concentric and tangent conditions are maintained. Design intent can be configured to maintain more, or fewer, conditions, such as keeping faces horizontal or vertical. We can get the same predictable results by pulling the outer face. Other CAD systems don't allow such edits because holes are driven from other features. As we make changes, including rotations, any rounds are automatically updated, and any blend patches, that blend intersections, are maintained. Dimensions in Solid Edge aren't just for 2D, and they are more than just simple PMI dimensions. Solid Edge dimensions can actually drive the model. Once added, these 3D driving dimensions can be dynamic to show values. You can also lock a dimension in order to maintain critical distances. Locked dimensions won't change during edits. No matter what faces you choose, design intent lets you control critical geometric conditions. Coplanar faces are maintained, and the value of that locked, 3D driving dimension, is kept. No system in the world allows you to make such flexible edits, while automatically maintaining design intent. An introduction to assembly modeling begins with simply positioning existing components relative to one another. But real engineering design begins with the requirements of the assembly as a whole, not its components. This makes top-down design, or modeling parts in the context of the assembly they serve, an important skill. In the next few minutes, you'll see how Solid Edge supports modeling assembly components within the context of the assembly. Our scenario begins when a brake disc has been selected for the final design of a motorcycle wheel assembly. Based on the diameter and spacing of the disc, we can now finish the design of the disc attachment to the wheel. Finally, we will design the shipping container for the wheel. To begin, we have a wheel whose design is not yet complete. We need bolt holes to attach a disc brake. With the disc placed in the assembly, we can define the wheel shaft hole locations with a Boolean operation, subtracting the volume of the disc mounting bolts from the wheel. Based on locations of the cylinders this produces, we'll use the hole recognizer command to fully define the bolt hole features. Now, we will design a container assembly for shipping the wheel. Starting in the context of the wheel assembly, we will create a part document. In that part document, we will use multi-body modeling to create a multi-layered shipping container. First, let's create a body to represent the inner foam container. Now we'll create a second design body to represent the outer, hard fiber container. We'll add rounds to the corners. And then, within the context of the part file, we'll subtract the volume of the wheel assembly to create a cavity within the foam container that positions the wheel. The foam container will be manufactured in two halves, so we'll split this design body along a reference plane. Our final object is a shipping container assembly, so let's publish the three design bodies in the case part as separate part files, and publish an assembly of these parts. The packing department requires assembly instructions for each package. The last task would be publish an exploded view of the shipping assembly. We provide help and training to get you started with Solid Edge quickly. The links you see here are just the beginning. Learn to use Solid Edge with searchable help, workflow tutorials, videos, and self-paced courses. Follow the links from the training page to the right Solid Edge learning path for your needs. Find starting points if you are new to CAD, experienced with another system, or just want to expand the skills you already have. Learn about the different tools available in Solid Edge by taking a video tour of the user interface. Search across the entire collection of help and training to find basic concepts, step-by-step procedures, and information on commands and dialog box options. The links on the startup screen are good places to begin learning to use Solid Edge. They will help you become more productive quickly.